Hi and welcome to this on Maths prediction for the AQA Higher Tier Maths GCSE Paper 3 2018. Enjoy! Hiya, okay, so I hope Paper 1 and 2 went alright. We've now removed the Paper 1 and 2 topics to get you a Paper 3 prediction. Like I've said in the previous videos, please use this in amongst all your other revision. There's plenty of topic busters on the site which cover all the GCSE topics, not just the ones in this prediction. The downside of a prediction is it can only be the amount of marks in the paper. There are plenty of topics that could come up that still haven't, and also the exam boards are notorious in repeating some of the previous topics. So use this as a starting point, or use this as a bit of a revision break, a revision check, but please also do the standard revision as you would normally, and see this just as a revision tool. Like always, you can do this online at onmaths.com. Also, if the servers get busy, which they normally do probably the day before the exam, then please use our backup site, which will be in the description. I hope you enjoy this video, and if you like it, please click like. If you really like it and want to see more from us, click subscribe. Thank you very much. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'm going to use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here, because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360, and we don't want the 100 one. You'd also get 260. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up, but I'm going to do this in pence. So I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down, over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark, but if you actually wrote the gradient as well, then you definitely get the mark, and sometimes it will ask you for the gradient and then ask you to interpret it. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59. So 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. For these types of questions, always make sure that you show your working, show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding, because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102. And then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees, because if you look at this, I'll use a different colour, this angle here and this angle here are z angles, or alternate angles. Or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. The place I always start with questions like this is just drawing a diagram so that I can get my head around what the questions ask me. So we've got three place names, Chelton, Bocco and Devley, and I'm just going to label them as C, B, and then we stop at Devley on the way, so I'm going to call that D. And normally place names and people will have different first letter, so you can just name them with their first letter. So distance from Chelton to Devley is 26 miles, so we know that's 26 miles. And the speed was 52 miles per hour. Okay, and the time he left Chelton was 9 o'clock. Okay, and so we're looking for the speed to get there at 9:45. Okay, so it's clear in this question that we're looking at the relationship between speed, distance and time, and most people use the triangle for this, which we've got speed, distance at the top and time at the bottom. And what you do with this triangle is just cover up the one you're looking for, and it tells you how to work it out. So if you cover up speed, it's distance over time. If you cover up time, it's distance over speed. And if you cover up distance, it's speed times time. So here we're given a distance, we're given a speed, and we're looking for the time. So the triangle tells me to do distance over speed, so 26 over 52. Now I can divide 1 by 26, that's going to be a half. So it's half an hour. So we know that David's going to get to Devley at 9:30. So that means that he's got to, well, let's have a look. I've missed out a piece of information there, that it's 17 miles. So the distance is 17 miles. and we now know that the time is going to have to be 1/4 of an hour. So we're looking for the speed, well, that's distance, which is 17, over time, which is 1/4. Now when you divide by 1/4, it's the same as timesing by 4. So if you've on the num calculator, you can do 17 times 4, and what you can do is, instead of 17, it's 10 and 7, 4, and that would be 40, that would be 28, and so you add them, so it'd be 68. Obviously if it's on the calculator, you can just type it into the calculator. So he's going to have to travel at 68 miles per hour to get there in time. When numbers are quite small, it's quite easy just to do trial and error to find the highest common factor and the lowest common multiple. But when the numbers are larger, then the way we do it is with product of prime factors. Now this could come up on a paper which has previously had product of prime factors, and this is distinct enough maybe to come up in its own right. So just because product of prime factors have already appeared, this question has already done that bit for you. So how are we going to do it with these large numbers? And 3,675 and 84 are pretty large numbers. Well, the way we do this is with a Venn diagram. Now I'm going to use the space down here to do this, and what I'm going to do is, because I find it easier, I'm just going to write it not in index form. And then when I do my Venn diagram, I can just cross them out when I've done them. So 2 times 2 times 3 times 7. Okay, so let's construct myself a Venn diagram. Okay. Now, I'm not very good at drawing circles, but I'm going to try my best here. I'm going to try and make the circles as big as possible. So we've got 3,675. I'm just labeling which circle is which, and this is 84. And to do the Venn diagram, we're just going to go through the numbers and write out which ones overlap and which ones don't. So if I have a look at the 84 first, we've got a 2 there. Well, 2 doesn't go into 3,675, so that 2 is going to be on its own there, and this 2 here is going to be on its own. Okay, I think that's it. So the next one, now this 3 appears in both lists, so this 3 goes in the middle. The 5 here only appears in 3,675, and same with this one. And then we've got 1 7 that appears in both lists, but we've got another 7 in the 3,675 list. So that's my completed Venn diagram. Now, to answer question A, to find the highest common factor, all you need to do is multiply the overlapping ones together. So the highest common factor is 21, and that's it. There we are, it's that easy. Now, to find the lowest common multiple, which is question B, what you need to do is times all of them together, every single one. Now you might wonder, well hang on, surely that's just going to give us 3,675 times 84, so why couldn't I just do that? Well, the overlapping ones we're only going to write once, so the 3 and the 7 in the middle, we're only writing them once. So we would, if we did 3,675 times 84, we would be timesing by 3 and then timesing by 7 again. So we've already done the middle bit, so we've already done the 21 in the middle, and I need to do the ones around the side. So we've got 5 times 5 times 7 times 2 times 2. Now on the non-calculator paper, it might be a bit more generous with the numbers. This one is probably going to be more on the calculator paper, although there are ways that you can do this. For instance, I could pair the 5s and the 2s up, and that would make 10. The 5 and the 2 there would make another 10, so we've got 100. So all we need to do is 21 times 7 and then put 2 zeros in the end of it. 21 times 7 is 147, so put 2 zeros at the end of it. If it's on the calculator paper, you just literally use your calculator to times them out. And so that's 14,700, well, the chances of us finding that with trial and error are close to impossible. So you can see why this method is so good. In this question, we're asked to compare two banks, and normally when I'm asked to compare something, I just put a line down the middle of the working out, and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all, I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%, so that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that and calculate 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers, you realise how to just go straight there. So it's going to be 1.018. But you could do 100 plus 1.8 is 101.8, and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312. And I'm going to round this to 42. I'm going to round it to the nearest penny. Okay, so that is super bank. That's how much we'd get. Now, the great bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%. And then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022, so times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I'm rounding it to the nearest penny. Okay, so it says, which account will give her the most money? Well, looking at that, it's going to be the super bank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be the super bank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much, so I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p, so £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer, and actually technically you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. and in this bit here you could have done all of this just as one bit. You could just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, so this is quite a complicated looking question, but the most important thing is we break it down. So it says a circle is drawn inside a square. Square has a height of 12 centimeters. So the first thing to know is it's a square. Therefore, the width is also going to be 12. And be careful to look out for that. Whenever you've got a square, they might only give you one of the dimensions. They won't always say it's a 12 by 12 square. Okay, so you've always got to assume that the other one, or you've always got to know that the other side is going to be the same. Okay, so let's work out the shaded area. So the thing we notice is it's like a quarter of the square, but with the circle removed. Okay, so the first thing to do is work out the area of the square. So area of square. Okay, so the area of the square is going to be quite easy. It's going to be 12 times 12, which is 144 centimeters squared. Okay, next thing to work out is the area of the circle. Okay, now this you need to remember the formula, which is pi r squared. Okay, and that you do need to know because you're not given that in the exam. So it's going to be pi times, and now what is the radius of that circle? So the radius is halfway across the circle. Now the circle has the same height as the square, or the same diameter as the square's height. Okay, so the radius is half of that, so it's going to be 6. So it's going to be pi 6 squared. 6 squared is 36, and we write that as 36 pi. Okay, now it's an uncalculated question, or it could be in the non-calculator, it could be in either. Okay, but it does ask us to give our answer in terms of pi, so we're not going to go any further than that. We'll leave it as 36 pi. Okay, so we need to work out the area of all of the outside. Okay, so we're going to do all of the outside. Okay, including this shaded bit. Okay, so area outside circle. So I'm trying to show the examiner that I'm working out the area that I've shaded in red. So the area of that is the area of the square, which is 144, take away the area of the circle, which is 36 pi. Okay, now to work out the shaded area, which is what the question asked for. Now looking at that, we've got 4 parts. We've got this part, this part, this part, and this part, and all 4 of them are equal, and we only want one of them. Okay, so to work out the shaded area, we get our answer from before and we divide it by 4. So we're going to divide the 144 by 4, and it's dead easy to divide by 4 because you halve it, then halve it again. So half of 144, well, half of 140 is 70, half of 4 is 2, so that's going to be 72. Then half of 70, half of 72 is going to be half of 70, which is 35, half of 2, which is 1, so it's going to be, what did I say, 36. So it's 35 plus 1, which is 36. Okay, next we're going to halve the 36 pi. So we only need to halve the number before the pi, and that would have the same effect. So we're going to halve 36, or we're going to divide it by 4, but we're going to halve it first, which is 18, then halve it again, which is 9. So we need to divide each one by 4. So I've divided that by 4 to get to 36, and I've divided that by 4 to get to 9. So my answer is 36 take away 9 pi. Okay, so this question is asking us to find unknown lengths. Now, the easiest way of approaching this question is to draw the 2 triangles, the little one and the big one, separately. So I'm going to do that really quickly. I'm going to draw the small one, and I'm going to draw the big one. There we go. And I'm going to fill in the length. So this small one has 37 here, and 17 at the bottom here. This big one has 50 down the side, and 34 at the bottom. Okay, now The second most important thing to realise with this question is that these two triangles are mathematically similar. The reason is that the top angle here is shared. These two here are both corresponding because they're off a parallel line, and it's the same with these two. And any two triangles that have exactly the same angles will always be similar, which means that one's an enlargement of the other. And with enlargements, we're always thinking about scale factors. So we've got to find out what you times 17 by to get to 34. So on my calculator, I do 34 divided by 17. I probably shouldn't need to do it on the calculator, because obviously the answer is 2. So if I'm timesing that side by 2, and I'm looking for length AD. Now AD is this one here. How do I get from 37 to AD? And remember, it's corresponding side, so it would be the left-hand side will go to the left-hand side. So I'll times that by 2. So it would be 37 times 2, which is going to be 74. So my answer will be 74. And the last one, let's do it in a different colour. Now we're looking for length CE. So CE is a bit of a weird one, isn't it? Because CE is this bit here. So all I need to do is work out what AC is, which is this one here. So let's work out what AC is. So to go from the big one to the small one, instead of timesing by the scale factor, I'm going to divide. So I'm going to divide it by 2. So AC is 25. Now if AC is 25 and the whole thing is 50, so let's try and make this a bit clearer. So the whole thing is 50 and AC is 25. So this bit up until this bit. Then CE must be 25 as well, because it's 50 take away 25, which is 25. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Okay, this is a basic circle theorem question, and the only thing we need to know is which circle theorem this is. Well, it's a quadrilateral with each of the points on the circle, so it's cyclic quadrilateral, and the circle theorem says that opposite angles in a cyclic quadrilateral add up to 180 degrees. So we just do 180 minus 65, which equals, I think, 115 degrees, so it'd be 115. And the response that they need is simply opposite angles in a cyclic quadrilateral. So opposite angles in a cyclic quadrilateral, I should write the whole thing. Opposite angles in cyclic quadrilateral add to 180 degrees. In most exams, they're just looking for cyclic quadrilateral as a reason, and normally you'd write down it in just the first part of the question it will say work out what x is and give reasons for your answer, and you just put in brackets cyclic quadrilateral. But it's always best to write too much than too little. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2. So what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done, so we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. Again, this question says y is directly proportional to the square of x. So to show proportional, we use this sign here. It looks like a fish. And it says that it's proportional to the square of x. So that's going to be x squared. Now to get rid of that fish, or alpha, whatever you would choose to call it, what we need to do is introduce a constant which we call k on the right hand side. Like so. And actually a lot of students miss out that first step and just go straight to the second. Y equals kx squared. Okay, now that's our general formula. but we need to find out what k is. So we're going to go off to the side to find out what k is. And I'm going to put in the values of 50 for y and 5 for x. So 50 equals k times and then 5 squared. And let's put in my lines. So that's going to be 50 equals 25k. Divide both sides by 25. And 2 equals k, or k equals 2. So we found out what k is. So we're back to our formula. And we know that y equals 2x squared. Okay, the reason we know that is because k is constant, it won't change. So if it's 2 for that situation, it's going to be 2 across the board. It says find the value of y when x is 4. So we're going to substitute 4 into it. So y equals 2 times 4 squared. 2 times 4 squared, so that's going to be 2 times 16. 2 times 16 is 32. So y is going to be 32. Okay, so this question is involving a probability tree diagram, and if we read the question, it says that the counter's not put back in the bag, therefore we know it's going to be conditional. Now conditional means that the probability of the second event, so taking the second counter, depends on what you did the first time round. Okay, the way probability trees work is you start on the left hand side and you have an option. You can either go up if you pick blue, or down if you pick red. Now because you have to pick one of the options, the two options have to add up to 1. So if blue is 3 over 7, the bottom one must be 4 over 7. Has to be, because then it adds up to 7 over 7, which is 1. Now if we picked a blue on our first counter, the probability of us picking a blue again is 2 over 6. So therefore the probability of us picking a red will be 4 over 6. Okay, now let's see where those numbers have come from. It says in the question that there are 3 blue counters and 4 red. Therefore the first probability of a blue being 3 over 7 is because there's 3 blue counters and there's 7 altogether. The second probability, so if I picked a blue on the first counter, went down, well, if I picked a blue again, to 2 over 6. That's because there's 2 blue counters and only 6 left altogether. So we need to know that to be able to fill out the bottom one. So if I picked a red on the first time round, what's the probability I'll pick a blue? Well, let's have a think. There are still 3 blue counters in there, but there are only 6 left altogether left in there because we've picked a red. So the probability of us picking a red, well, there were 4 before we picked one, but we've picked a red, so therefore there are 3 reds left and 6 left altogether. Now I'm deliberately not cancelling these down. I could cancel it down to a third, 2/3, half, half, but I'm just going to leave it as it is for now, just to make things simpler. Okay, question B says work out the probability that the 2 counters picked are different colours. So let's follow our routes along. I'm going to go up and then up, so blue and then blue, blue and then red, red and then blue, and you're always starting from this point here, and then red and then red. Now let's have a look. Blue and blue are not different colours, so we're not interested in that. Red and red are not different colours, but the middle two are. So what you do with probability trees is you start here and you collect all the fractions that you went past on your way, on your journey to the end. So we went past 3 over 7 and 4 over 6. Now the word and there is really important because and in probability means times, and you're always going to multiply them when you're going across a tree diagram. So I'm going to times the tops and times the bottoms. Again, I'm not going to bother cancelling down at this point. Okay, so the other option is I pick a red first and then a blue. So that is 4 over 7 and, mean times, 3 over 6. That's going to be 12 over 42. And normally these two will be the same. Okay, so just be prepared for that. Not always though. Okay, so we had 12 over 42 for the first option and 12 over 42 for the second option. but we can't pick both options, and this is the problem. We've got two probabilities, two answers. Well, we can't possibly have that. The word or comes into effect here. We either pick a blue and then a red, or a red and a blue. And the word or in probability means add. So all we need to do to finish this question is add the two options we had. So when you're going down here and you're collecting all the fractions you got, you just add them together. So we're going to add the tops together, which is 24 over 42. So it's half top and bottom, and let's cancel it down now. 12 over 21, and I think I can divide them both by 3, so it'd be 4 over 7. So my answer is 4 over 7. Okay, so this looks like it's a kind of quadratic question, but it looks a bit of a mess. There's a really easy first step to sort this all out, and that's to times everything by y squared. So just times literally everything in the equation by y squared. So 5 over y squared times y squared just leaves 5. And here we've got 7, and in fact I'm going to write this as a fraction still so we can see it a little bit clearer. So we've times that by y squared, but we've not really dealt with it yet. And we've got minus 3y squared equals 0. Now the y at the bottom and one of the y's at the top cancel. So we end up with 5 plus 7y minus 3y squared. And since we'll use the quadratic formula on this, it's probably easier I put it in order. So that would be minus 3y squared plus 7y plus 5 equals 0. So we've got to find out what a, b and c are. A is the number before the y squared, which is minus 3. B is the number before the y, which is 7. And c is the number on its own at the end. Then we're going to use the quadratic formula, okay, which is x equals minus b plus minus square root of b squared minus 4ac over 2a. Okay, so I'm just going to type that all into my calculator. It's a lot easier doing this than going through. I'm going to do plus first, and then I'm going to go back and change that. So minus brackets 4 times minus 3 times 5, close brackets over 2 times minus 3. Press the equals, and I've got an answer of minus 0.57338, blah blah blah. To two decimal places, that's minus 0.57. I'm going to go back on my calculator and change that plus to a minus. And it also equals 2.9067, blah blah blah. So that's going to be 2.91 to two decimal places. And so the trick with this is just convert it into something y squared plus something y plus something equals 0. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency density and class width were at the bottom and frequency at the top. Now it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these, because I'll need to know what they are. So the first class width, where it's 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10, and the last one's 15. So when I've got the class widths, I can work out the frequency density. And the frequency density is the frequency, according to the triangle, divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well, that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator, it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2, so can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, so that would be perfect. So I can go up in ones on the 5 squares, so it would be 0.2 here, because they're 2 squares, 0.4, 0.6, 0.8, 1.0, or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high, and it's 0 to 10, so we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20, and it's 0.1, so it'd be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one because it's only one square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40, and we want it to go across here. So we're looking for an estimate for the amount that are in here. Well, if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6, because the total frequency for that bar is 6, and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4. There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of function, x equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. Now the major rule with algebraic fractions, or fractions generally, is that the denominators must be the same obviously at the bottom, that's where denominators are. They must be the same when you add or subtract. So we've got to make both of the denominators the same. So what I can simply do is times the left hand side by the right hand side's denominator and the right hand side by the left hand side's denominator. Basically I'm going to times both top and bottom of this side by x, and then both top and bottom of the other side by 10 plus x. So 11 times x over this 10 plus x by x as well. Now I've kept that fraction the same because I've times top and bottom by the same thing, so it's the same fraction. That's important that you don't change the fraction. Then I'm going to times the 5 by the 10 plus x, and I'm going to times the x by the 10 plus x. Now something I've done instinctively, and a lot of people make mistakes on, is I put brackets around the expression 10 plus x, and if you don't do that you will end up, say here, just timesing the x by the 10 and not timesing the x by the x on the right hand side. So always put expressions that are in fractions in brackets. Okay, so now the bottoms are the same, we can just simply add the tops, and I'm going to expand that top bit. So 5 times 10, which is 50, 5 times x, which is 5x. I'm going to expand the bottom, but you don't need to. So the bottom will stay as x brackets 10 plus x. The bottom, in fact, let's do that step first to make it really clear. Okay. So, and I'll put an equals there. Okay, now we've got 11x plus 5x, which is 16x plus 50, over, and I'll expand the bottom one, so it's 10x plus x squared. So my answer is 16x plus 50, and you normally do by powers of x, so I'm going to do x squared plus 10x. Now unless it explicitly tells you otherwise, you don't need to expand brackets, so you could leave the bottom one in brackets, but I needed to expand the top one because I was adding the 11x on. So if it's literally like that, I wouldn't have needed to expand it, I could have just left it in brackets, but read the question because it might ask you to. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something. Okay. Now we've got 2x squared, and so minus something x. We've got 2x squared minus 28x. So we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it, that's completing the square. Okay, so I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimeters at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that. So that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angle triangle here, we have two of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimeters and 5 centimeters, and all of them in centimeters, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras. So we're going to square them, add them, and then square root it. And we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61. And we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Whoops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11. And we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places. So the answer I'm going to write is 54.62. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So, in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5, and that gets me 1.81712 blah blah blah. Okay, now I need to keep that answer, so what I'm going to do is I'm going to press the cube root button, then I'm going to click inside the root, I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers. And it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5, and we've got 1.9034 blah blah blah, cube root button, answer plus 5, and we've got 1.9040 blah blah blah. Now we're looking for 3 decimal places, so the numbers we're looking for being the same is these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah, blah, blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer.
Okay, I hope you enjoyed that video. Like I said, you can do the questions online. On the online paper, all the numbers constantly change, so you're not just remembering answers, you're remembering techniques. We also have the new Revisionator online, which is a really, really good tool to just do random questions. We also have mock exams, demon questions for the harder questions on the GCSE course, mini mocks, and there's all sorts of other things on the website. We also have the remaining topics on our website, which you can just go through all the exam questions we have for the remaining topics. If you like this video, please click like, and if you want to see more from us, click subscribe. Thank you very much.